Good morning, everyone. My name is David Pinn. I'm the head of strategy at Brain Corporation. And let me give you just a little introduction to our company. So we were founded around 2009 by a team of neuroscientists, and we have a focus on software for autonomous mobile robots. The company is based in San Diego, California, and we have about 150 employees. And we're funded by SoftBank Vision Fund and Qualcomm Ventures, who both really share our vision for a world in which robots are all around us, helping us with our day-to-day lives, in stores, in malls, in airports, in our homes. And so the question that I really want to talk about today is, where are the robots? What is needed to scale so that we can actually see robots in our day-to-day world? And I want to leave you with 3 ideas for what it will take to scale robots so that we see them in the world all around us. So where are the robots of the future that we all thought would exist by now? Well, what I would suggest to you is that actually they already exist today. They're all around us. But the reason why we don't consider them robots is we need people to drive them around. What we do at Brain Corporation is that we're able to turn manually driven machines into autonomous vehicles. So I have a video here just to give you an example of a machine that Brain helped to develop. This is a store in Los Angeles, California, a retail warehouse store, and you can see 2 floor scrubbing robots here approaching us. And what Brain does is we partner with the companies that make the manually driven machines to turn them autonomous. And I think what's really important here in terms of providing a scalable solution is the way in which we're able to deploy these robots. These robots don't require any infrastructure in the store. They don't require any prior knowledge of the layout of the store, and they don't require any special training for the employees of the store. The way it works is I can mail one of these robots to any arbitrary location, and the janitor that's used to cleaning the floor with a manual version of this machine simply pushes a teach button on the robot, drives it around as they always drive their cleaning route, and then the next day, when they're ready to clean again, they hit replay, and the robot drives itself, essentially following the exact same path that the janitor took to train it, but of course avoiding obstacles and pausing for people, as you can see here in the video. So idea number 1 in terms of scaling robotic solutions is to make sure that they're easily deployed. It's really not practical if you have to send a team of PhDs out to every grocery store in the country in order to deploy robots. So specifically what Brain does is everything in orange here. We provide a reference design to the manufacturers of manually driven machines. Includes all the sensors, which are LiDARs, 3D time-of-flight cameras, compute platform, and then of course the software that goes along with it to help the robot localize itself in space, detect and avoid obstacles, etc. But what I think is really important in terms of scaling robotic solutions is the piece that our partners provide. And I think this is sometimes lost on the robotics community, which is all the functions that these manufacturers of manually driven machines provide is what enables these solutions to scale. They have global sales teams, global support, large manufacturing capabilities, and most importantly probably is domain expertise, right? In the case of example, which is a floor cleaning robot, they know how to clean the floor, which is critically important obviously in a floor cleaning robot. And our expertise, again, is really on the autonomous navigation, not on the specific end application. So idea number 2 is, to the extent that there are manual machines that can be robotized, leverage those machines. But of course, there are some applications for which there is no manual machine. We have to create a new form factor to provide some robotic solution. I'll give you an example here in delivery robots. So here there's roughly a dozen different delivery robot startups, pictures that I took off the internet. And you can see that the form factor here is very important, right? The type of form factor that you want for a hotel delivery versus a hospital delivery versus a warehouse delivery. They look very different, and this is entirely appropriate. But one issue I think that a lot of these robotic startups face in terms of scaling is that they have to worry about a lot of different things. As I mentioned, they have to create a form factor that's appropriate for their application and worry about all the business side of dealing with their specific vertical. But on top of that, they have to solve all the general purpose robotics problems as well. And it's a lot for one startup to take on. And so what we do at Brain Corporation is we provide startups with an ability to really focus on their application and not concern themselves with the general robotics problems that exist across applications. And I'll show you an example of what this looks like. And so we talk about here equipment manufacturers, companies that make manually driven machines that can be automated. We're also talking about robotic startups that are creating new form factors for robotics. Both of these types of customers, they need to solve the same very general purpose robotics problems: localization, obstacle detection, obstacle avoidance, cloud, IoT stuff. And so what we provide at Brain is the Brain OS. And this is the navigation software, navigation hardware reference designs, and a cloud-based fleet management and reporting solution that allows these companies really to focus on their core application rather than focusing on already solved problems in robotics. And so they can take Brain OS, apply their specific knowledge in their domain, and provide a complete solution for robotic application in any number of verticals that they might choose to focus on. So just to summarize, 3 ideas for scalable robotic solutions. Number 1, we have to ensure that the deployment of the robot is as easy as possible. This means minimizing changes to infrastructure, minimizing the requirements to have special training on site. Number 2, the idea of partnering with existing manual equipment manufacturers rather than reinventing the wheel. And number 3 is spending resources on application-specific issues rather than trying to resolve general purpose problems that can be solved by others. Thank you very much.
Brilliant. Thank you so much.